This is our first problem involving the simple pendulum. Find the energy of a simple pendulum with mass L and length L exactly. Well, to begin, let's basically sketch out what the simple pendulum looks like. You have a pivot point, a rope or the rod of length L, a mass at the end of length of mass M, and so this is length L. Right? And so we want to calculate the energy of this thing exactly. Right? So let's recall the energy is equal to the kinetic energy plus the potential energy. Right? Let's do each of these in part. Right? So the first thing to realize is that this pendulum is well described by an angle, theta, which is the angle from the vertical position. Right? Now, the distance which it moves basically here, which is ds, this is going to be L d theta. Right? And if I want to calculate what the potential energy has to be, I would need to, what the kinetic energy needs to be, I would need to basically look at that angle as a function of time. We just switch pens. This pen's getting bad. Okay, so let's do this. Right, so the kinetic energy is going to be 1/2 mv squared, which is 1/2 m ds dt squared. Okay, but this is just simply 1/2 of m L squared d theta dt entire thing squared. That just comes from this. Alright, well that part of the kinetic energy was pretty simple. Let's get the potential energy. The potential energy, on the other hand, is just as follows, basically. It depends on the height relative to the y equals 0 point, right? Where it would be if this thing was at theta equals 0. Alright, so this is the distance relative to that. So in that case, the potential energy is just mgy, and we have to calculate what y is as a function of basically this angle theta. Okay, so this is going to turn out to be, this length here is going to be L cosine theta, and we want to get this difference here, that's y, right? And so this difference here from the entire length, which is L, is going to be y, is going to be L minus L cosine theta. Right, so this is just going to be basically mgl minus mgl cosine theta. Right. So let's plug all these things together. The energy, which is the kinetic energy plus potential energy, is 1/2 m L squared d theta dt squared plus mgl minus mgl cosine theta. And this is the energy of the simple pendulum exactly. Hope that was helpful.